right, we're going to see how well my voice holds up today. Battling a little bit of a cold. Today we're looking at geometry, lesson 60, proportionality theorems, which is the relationship that exists for any line that intersects two sides of a triangle and is parallel to one side. We'll also look at lines crossing, transversals, parallel lines, those types of things. So let's get into our definitions first before we start looking at actual questions. Theorem 60-1 is our triangle proportionality theorem, which is if a line parallel to one side of a triangle. So what they're saying is that this line that comes across here, line AB is what we could call it, if it runs parallel to YZ, then it divides those sides proportionally, which means that XA over AY. I know that what we're looking at here, let me see if I can write this up a little bit better the way that we would normally write it in a proportion. We'd normally write that as XA over AY is equal to XB over BZ. It's just kind of hard to type that in. It doesn't want to do that very well. All right, so it divides the segments of those triangle side lengths proportionally. Okay, so we want to understand and be able to come back to Theorem 60-1 to solve questions that match with it. Theorem 60-2 is the converse of that proportionality theorem, mainly stating that if it divides the triangle proportionally, if I know that XA over AY, again, let's put that as XA over AY, if I know that it is proportional to XB over BZ, and we start off with that information, then I know that these lines, are parallel. I got this strange little arrow there. So we know that these are parallel. Okay. So one starts off with knowing that they're parallel and therefore stating that they're proportional. This one starts off with the proportion and allows me to say that they are parallel to each other. Okay, and that's going to help me with things along the lines of like angles. Notice that anytime we have two parallel lines cut by a transversal, we can get things like angles, alternate interior, same side interior, or mainly corresponding angles. Sorry, my brain's a little squishy today. All right, Theorem 60-3, this is where I'm telling you it's not just triangles. If we have parallel lines that intersect transversals, then they divide the transversals proportionally. Again, let's see this as an actual proportion. So if we have AC over CE, okay, AC, this length here, over CE, it's going to be proportional to BD over DF, this length over that length. And they're not giving you any numbers here, but we'll see some numbers as we work out some problems here in just a second. Okay, Theorem 60-4. Let me see if I can move this around a little bit here. Slide that over. If parallel lines cut congruent segments on one transversal, then they cut congruent segments on all transversals. Okay, meaning that if and I know that my picture here is probably not super accurate, but if I know that this length is the same as this length, then I know that I've divided this into congruent segments down here. Okay, I think that's the bulk of the theorems that they give us. So let's see if we can answer some questions. All right, let's come down to one where we see question number 1 here. All right. We want to find the value of y. Okay, find the value of y. All right, so this is based on a proportionality theorem. Okay. Let's see, so we would do same side over same side. So what I have here is 9 over 3 is going to be equal to y over 7. Y over 7. Let's see, 9 times 7 is 63. 3 times y is 3y. Divide by 3 on both sides to solve for y, which is what it says here that we want to solve for. 63 divided by 3 is 21. Y equals 21. I get my answer right there. Okay. All right, if you have any questions about that, feel free to pause the video, raise your hand and ask. All right, let's come down to our next question. Number 2, find NP. Now that's, okay, find NP. NP is right here, so let's identify that. Let's see. Let's call that x. That's going to be x over 5 is going to be equal to, I'm going to do that short link there because it's there, 2 over 8. Okay, cross multiply and divide. So 10 equals 8x. Divide by 8. X equals 10 eighths. 10 eighths would be 5 fourths. 5 fourths. Or 1.25. 1.25 should be right there. Okay. All right. A little bit more involved question coming up here. Number 3. It says verify the NQ is parallel to PR. Okay, verify the NQ is parallel to PR. So this should use that converse theorem. What we want to see is that if PR divides it proportionally, then it is parallel to NQ. Okay, so we need to check and see if it's proportional. So we're going to do 16 over 12 and see if that is equal to 8 over 6. Well, you could cross multiply and divide, just cross multiply, or we could reduce both fractions. 16 over 12, both of those things will divide by 4. 16 divided by 4 is 4. 12 divided by 4 is 3. Okay. 8 and 6 will both divide by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. So they are proportional. And so we can look through here, and I think that you'll see in A what we kind of are looking for here. This 16 twelfths equals 4 thirds. That's NP over PM. Okay, NP over PM, which is what we did. Okay, and QR over RM is 8/6 equals 4 thirds. Since those two things equal each other, NQ is parallel to PR by the converse of the triangle proportionality theorem. You notice that you could go through the rest of these and see why they are wrong. Kind of take you a quick glance at that. Okay, it's not that they're all necessarily, we see 4 thirds on B, 4 thirds on B, so why is that incorrect? Well, let's see. The B here does NP over QR. Okay, they do 16 over 8. Okay, that's what NP over QR is. You'll notice that QR is not 8, right? That's why we could go to that one and see why that doesn't work. Okay, and you're going to see similar problems to why a lot of these don't work. Now, they do all use the converse of the triangle proportionality theorem to prove it, but their ratios and proportions are incorrect. All right, let's come down here to number 4. Number 4, an artist used his perspective to draw guidelines in her pictures of a row of parallel buildings. So we know that the buildings are parallel. How many centimeters is it from point B to point C? What is missing in this picture, and I'm going to go ahead and include it, okay, is 5 centimeters right there. For whatever reason, it got cut off. Okay, so we'll include that on there from there. Okay, so if we're looking for this, then we can do 4 over 3 is proportional to 5 over x. So 4x equals 15 by cross multiplication. And 15 divided by 4 is 3.75 centimeters. 3.75 centimeters. Okay, 5 is bringing us into that fourth theorem. All right, in the diagram, AB, line CD, line EF are all parallel. We want to find the length of AC. Notice this, okay, that those are equal to each other. Okay, that is why what we're going to end up doing, you could set this up as a proportion, but I think if you go back and look at that last note, okay, if parallel lines cut congruent segments on one transversal, then they cut congruent segments on all transversals. If UV equals VW, then XY equals YZ. So let's go back to this because we can actually make this a lot shorter than just doing a proportion. Because BD equals DF, then I know that 3x minus 21 equals x minus 5. Okay, we could subtract x, add 21. 3x minus x is 2x. Negative 5 plus 21 is 16. 16 divided by 2, x equals 8. Now, you still could have set that up as a proportion where you would do 3x minus 21 over x minus 5 equals 2 over 2, and then cross multiplied and did all of that. It'd take you several more steps. You would still end up getting x equals 8. All right, but it says, before we're finished here, it says find the length of AC. 8 is not my answer. We want to know what AC is. So we need to take, now granted, the easier way to do this is you could plug 8 into x, 3 times 8. Let's see, it was 24. 24 minus 21 is 3. Or you could just do, because we know that this length right here, CE is going to be the same, we could just do 8 minus 5 and get 3. Okay, it's a little bit quicker that way. We don't have to do as many steps. Get the same answer either way. Okay, 6. 6, find QU. All right, we're showing two parallel lines dividing this segment, so it should divide it proportionally. So 12 over 5 equals x over 4. Okay, so we've got 5x. Looks like that equals 48. Divide that out. And you plug that in your calculator because we know it's not going to go in evenly. We could get 9 3/5 or 9.6. 9.6. Okay, either one of those answers will work for number 6. Okay, let's come down to number 7. I think this is our last question. I feel like these are all fairly easy. The question here is segment ST parallel to QR in the diagram? The way to check that is to see if it divides the triangle proportionally. So is 3 over 1 equal to 4 over 2? Okay, and the simple answer is 3 is not equal to 2. Right? If 3 divided by 1 is 3, 4 divided by 2 is 2. So the answer is no. Okay, it's not proportional, so therefore it is not parallel. All right, so hopefully that'll help you out there a little bit today. If you have questions, like I said, stop, ask, pause the video, write down those notes, anything that's going to help you out. All right.